All right, so this is Azure Chaos Studio, deliberately introducing faults. If you were looking for another talk, you are in the wrong room. So my name is Rhodes. I'm a Microsoft MVP. I'm a principal at EPAM Systems in the Azure Cloud Delivery Americas division, whatever we're called. I do Azure work. I'm a Microsoft MVP. It was for Azure. They changed the groups. They moved from Azure to now to something called just called Internet of Things. But I'll change that eventually. And I join Teams calls pretty much throughout my day. My window pops up, I click join, and that's pretty much what I do for a living. What we're going to be looking at is in preview. I not only say that it's in preview to say this stuff might change. It also might have changed since I started putting slides together or something. So like if I'm out of date, my apologies. I try to keep up to date with it before the talk and update all the slides, but sometimes I might miss something. Okay, so in this talk, we're just going to talk about chaos engineering. What is it and what it can do for your organization. And then we'll talk about Azure Chaos Studio and how to use chaos engineering in Azure. So this is probably what your current architecture looks like. It is probably not documented like this, but this is the reality of the situation. It's a big machine with a whole bunch of different pipes and wheels and whatever, moving things along in a way that you and you alone, because you've been with it for 5 years, know what's going on. And a lot of the times, people will see something like this big wheel over here. That's my I don't know, my topic or queue or whatever. That's important. I know how the data goes through that, so I want to test that. And I want to make sure that I have tests for when that fails and see how it works. But then people don't test other things. We see that water tower sitting at the top. Nothing's really using that water tower, but if it collapses, it just destroys the entire structure because it's a giant thing of water that just dumps things everywhere. Or they don't really notice after all the time they spent building this application that over the years, this little widget down at the bottom actually is what drives the whole machine. And if that goes down, the whole thing stops. A more real-world example. This is, I went to the Azure Architecture Center, and I clicked through until I found a diagram that I could just throw up here and start pointing out pieces of. What took the longest time is Azure Chaos Studio has so few integrations right now that I had to click through until I found one that was actually using the services that it could turn off. So let's say you want to test what happens if in this application you have an outage at Twilio. Who here uses Twilio? Right. Y'all probably have a good idea what Twilio does, right? How many of you have a backup if Twilio goes down? Yeah, me neither. Right. People just aren't going to get those messages. Yeah. Right, yeah? Maybe it's my two-factor authentication, but who cares? Maybe it goes down. Who has test right now in their test suite to just turn off one container or one container type within their Kubernetes instance? Right? So what happens if you do a deployment and somebody decided to put an infinite loop in one of the containers and somehow that made it to production? What happens? Do you know about it? What happens if your container registry suddenly is offline and you run through your pipeline? What happens if Cosmos DB fails in one region? Are you properly set up for the failover? Is it handling it for you? Did you set it up in a way that now that it failed over, it's on the other side of the planet, and every time you try to make a request, it has to go across the Earth to get it? So those are the things we're looking at to test with chaos engineering. I wish I could project as well. I can't do it. I wouldn't make it through the talk. We could. I just wouldn't make for a good YouTube video when they put that up. So chaos engineering, a methodology that helps developers attain consistent reliability by hardening services against failures in production. The first time I heard about chaos engineering was Chaos Monkey when Netflix made it. Right? It was a big deal. Everyone was talking about, look at this cool new product. And over the years, every time I see something come out of Netflix, I'm just going to be a stick in the mud about it. I'm like, you had unlimited money to do whatever you wanted to do. Of course, you made some cool stuff, but how useful is it to everybody else to have something that goes and turns off my stuff in production? Like, I don't know how useful that is for me. And that's why I put the line through in production, right? Their big thing was, oh, you got to run it in production. You need to start turning off services in production. So I worked in oil and gas for a while. And oil and gas, a lot of it is there's this big pipe. And in that pipe, money goes through that pipe. And if you ever work in oil and gas, you know what that means. It doesn't matter what's going on, you never turn off what's going through that pipe, right? The building could be on fire, and the only way to stop the fire is to turn off it. You still don't turn it off. That's where the money goes through. And if you work in retail, they're similar, right? When you go to deploy to production, they're like, no. Why are you deploying to production? It works now. People are buying stuff right now. Why are you deploying? So I don't personally agree with Netflix saying you should run it in production, because Netflix has a very different user base and user experience than the rest of us have for our industries. So I decided to take that out. So we want to start injecting faults. We want to start testing, doing our chaos engineering by injecting these faults and taking dependencies offline. Again, like I asked earlier, plenty of us don't have an actual test case for when things that we don't own are down. We want to start restricting access. Give me a second. Trying to remember exactly where are my slides. Again, my apologies, the first time I've given this talk, so I'm trying to remember exactly what I was trying to say. You want to restrict access. So this isn't about injecting faults, but it is. You want to restrict access to who can inject faults, right? You don't want to give access to your environments and have just a wide range of people who can start turning off things in any of your environments. And you want to force your failovers. This is just standard DR practices, right? You want to test and make sure that anything that you're turning off can actually fail over properly. It's really difficult to actually test your stuff at scale, because like we showed the big water tower with the windy wheel and all of that, unless the water tower's full of water, it can fall over and not really affect the machine. But once it's full of water, it takes things down. In fact, I'll segue yet again to another story. Does anyone remember, I've been doing this long enough now, it was like 6 or 7 years ago, all of Microsoft Azure went down because of a lightning strike in Texas. Do you guys remember that? Does anyone remember the retrospective on what happened? All right. So despite telling every single person in this room to make sure that they had proper failover regions, Microsoft was hosting Azure Active Directory primarily out of the Texas data center that got hit by lightning. Lightning struck, systems went down, the cooling system went down, as things started to overheat, they did exactly what they were supposed to. In fact, everything worked as it was supposed to. Started to overheat, things started to turn themselves off, and it started to reroute traffic to other regions. But Azure Active Directory was so large that the moment it started to redirect traffic, the other regions went down.
Also, Azure AD had hard-coded that they had to use Texas for one of their ops?
It was just where it was running. So it was the primary, and the high availability failovers couldn't handle the traffic the moment that it swapped over. I guess they had never tested at that scale. So it's hard to test that. I mean, think about it if you're on the Microsoft AAD team. How do I test my Azure Active Directory going down and have the, I don't know, hundreds of millions of requests that probably go through it every hour? How do I test that? And this is just something I want to talk about because I thought it was very interesting on how to actually test like this. I made my own slides for it, but I'm borrowing it from a talk from a high-frequency trader. So high-frequency trader, they have very different setups for how they have to run. And what they have to do when before a machine gets, what's the proper term? Utilized in production, it has to be warmed up. So we all know what we can control on the machine. We can run the application, we can put things into memory, blah, blah, blah. What you cannot do is you cannot tell the actual hardware what to put into cache, right? So what they do is they actually record their production traffic. So whenever a request comes in, they've got a network splitter. That splitter can send that network request to a recorder and to actual production. What they do is, when they want to warm up the machine before it actually enters into the cluster to handle request, they actually replay the network traffic. And in their world, they have special network cards that you can just turn the network off, but it still goes through the entire network traffic process. It just doesn't send out at the end. You can actually replay it, and that'll warm up the cache on that machine. I'm telling you this because if you need to replay your network traffic for your test, you can do something similar to try to get to a similar-ish result for your chaos testing. you can record what comes in as your actual network traffic at the front door of your applications, record it, and then in your non-production environments, depending on your compliances, HIPAA or FDA, whatever, depending on those, you can then replay that in your test environments. And that way you can actually see what happens to your system. Are there any questions after that long spiel? All right. Some of you had, I have a question look on your face, that's why I stopped.
Because usually your non-prod environments, I mean, our prod environments are all premium SKU. It's all standard SKU in pre-prod environments. Would we also have to upgrade to premium for testing? Well,
my suggestion would be to not really be doing this in your non-prod. When we do environment separations, we consider QA can be multiple different types of environments depending on the test we want to run. And you could have a chaos environment that would have premium SKUs that is not on for any life cycle outside of just the test, so that you only pay for the time it's up. Mm-hmm. Yeah, because otherwise, when management got the bill, you would no longer be able to run chaos tests. Yeah. Okay. So you're looking to figure out how resilient your system is, how can it manage and recover from these disruptions, and then the disruptions are those potential causes for failures for users, which can impact which can result in negative impacts. Some things you want to do, I mean, maybe you want to build test cases to actually reproduce an incident. I mean, if your system goes down because Cosmos DB is offline, probably time to write a test so that you can then test that again later and put it in your test suite. You can run game days. So I got retail clients. Anyone in Azure has retail clients. Who here is in retail or something similar? I just lied to you. It's not a single hand. Okay. Well, I have a lot of retail clients. They don't go to Amazon because that's their competitor. But anyways, game days, Black Friday or Cyber Monday. You got to run a game day. If you miss, if a system goes down on Cyber Monday, you just update LinkedIn. Your disaster recovery and business continuity drills, right? This is something that companies do scheduled a lot of the times, and you could kind of automate your test on BCDR just to test, I told you we have this SLA, here's what happens when these systems go down. Same thing with high availability. How many people actually test that their traffic manager in Azure will switch or anything like that? We just hope it will. Performance benchmarks, that goes along with capacity planning. How much can I put through there before it starts to break? And then from that, now I can set up my monitoring appropriately to alert me before systems start to go down. And then stress and load test and validating the actual tooling and data that you're using to monitor these systems.
For this, you need a system not to record it. I need a system like if I don't have a system to record, then what should I do?
A system to record like your network traffic?
Yeah.
You can run it the same way you're going to run any other test, automated test in your suite. You could use just fake data, junk data. Because if you're testing, like, does my Kubernetes, if these containers go down, does it return an error or does it just absolutely take down the system? It's different than I want to see exactly what it looks like under load. So you don't have to record exactly. Just like all your other tests, just have some fake data that you can send through the system to make the test work. Okay, so what we really want to take away from doing this, because management has to be sold on this idea, so you have to tell them not just that it's cool and is great, you need to tell them that it's going to increase service resiliency. You also are going to tell them how you're going to apply it continuously so that today it's not just a one-time thing. This is going to, as we go forward, make sure that the systems are not crashing. You're also probably going to tell them that we could use an entire team. I mean, we have, over the years, as you've seen, taking what was a singular testing team and expanded upon that concept to have very broad subcategories of that, and then a chaos engineering team is something that, and I'm pulling this from Microsoft's recommendations, is something that you would also want as well. And then you would also, this is also, again, when you're selling it, a best practice for testing is to actually test your environment in real-world scenarios. For applying it continuously, obviously, we all know how testing pipelines work. Yes?
Just asking a question on the chaos engineering isn't that more, or why is that not part of the DevOps team? If it is something to be applied continuously, something you spin up, run, last, whatever today's day of the week is against before periodic deploy or something like that.
I guess it depends on how you look at it. Do you see it as a part of the pipeline or environment setup, or do you see it as part of the testing suite? And who owns it, I guess, would be how you look at it, because where we put teams is really up to the organization.
Okay, thank you.
So when you deploy new code, right, as we all know, that's what the test suites are for. I deploy new code, I can make sure that someone didn't hard code something to something somewhere that takes down the system. If I start adding dependencies, I can make sure that, oh, well, you know what? I need now this new Redis cache in between these two. And if I've got a new dependency, I've got a test. I can add a test case and make sure. And I can also add in a test case, or use my old test case to make sure that that new dependency doesn't fail for the other systems going down. I can use it to observe the changes in usage patterns, and I can use it for mitigating problems. Okay, so for your chaos engineering team, this was the actual split that Microsoft suggested in building your engineering team. You have attackers. They're the ones that are in charge of actually writing and injecting the faults into their different test cases, and they provide hints as to what's going to happen. And then you have your actual defenders, which assess what's happening when things start going down, and then analyzing it and mitigating it. Goals. So when you make that team, you want to. It's a world star video over there, man. You want to familiarize your team members with monitoring tools. You want to recognize your outage patterns. You want to learn how to assess the impact of those outages. Did we lose transactions? Like, did something get halfway through and somehow the payment got processed, but we didn't record it in another system? You want to determine the root cause, so root cause analysis and mitigations. And you want to practice log analysis. So start with a hypothesis. Measure the baseline behavior. So before you inject your faults, then inject your faults, and then monitor the resulting behavior. Document the process and observations, and then identify and act on the result. So we let Cosmos DB fail over, and then nothing worked. Maybe something like all existing transactions to Cosmos DB failed and did not retry, and that didn't propagate right to the system, or something like that. Or you had eventually consistent setup in Cosmos DB, so the record didn't write, and when you read later, it was wrong. That kind of thing. Challenge your system assumptions. Validate change, so the topology, the platform, the resources. Figure out if you're actually meeting your SLAs, and use that SLA of the services that you're using as buffers. And then use live site outages as opportunity. Like I said earlier, something actually does go down. Just recreate it in a test. Okay, so best practices according to Microsoft. We're going to see if I can remember exactly what all these mean, because they're like 2 words each, and it's not my domain. Shift left. Shift left is their way of saying the continuous, right? Put it in your actual CI/CD pipeline. It'll apply every time you're in front of it. That's where your test run. Shift right is when you have an outage. Yes, live environment outage, and then testing against actual customer use cases or actual outages that you had. Blast radius. So best practice is to know your blast radius and monitor your system while you're running your test, because the blast radius is what is allowed to go down. If, in our example, you're turning off the oil pipeline and the well blows up, you're in more trouble than you were not testing it. So make sure that you have your blast radius in scope, you're monitoring, and you turn off the test if you start blowing things up. And then have actual budget for your error testing, and make sure you're watching that, because if you're spinning up all these premium SKU environments, somebody's going to notice. And you don't want them to notice when it's time for them to notice. So considerations, have you identified faults that are relevant to the development team, right? Do you develop, rooms mostly developers? Okay, so you probably know, and you've probably thought as we were going through this talk of what you wanted to try to turn off or blow up in the middle of your test. So identify those faults that are relevant. Again, have you done this in a way that accurately reflects what you've already experienced in production? And have you built your own team's confidence incrementally as you keep expanding your test coverage? Okay, so that was chaos engineering. I'm not an expert. I was just kind of giving you the overview of it and best practices guidance from Microsoft. Are there any questions before I move forward? All right, let's talk about Azure Chaos Studio. So what I talked about before where we were looking at those dependencies, Azure Chaos Studio is in preview. It's not that integrated with a bunch of different services. Right now, we can test that Cosmos DB instance, see what it does. We can test all of Kubernetes. There's a ton of stuff we can do against Kubernetes. And then we can test virtual machines, which aren't listed here. And as far as I know right now, those are the only three things you can do. Cosmos DB, Kubernetes, and virtual machines. So it's pretty limited right now, and they need a lot to really expand this scope. And this is something that is probably going to be slow to, in my opinion. I don't know, tomorrow they come out and they can have everything. My opinion is probably going to be slow to expand. I could assume the meeting that you're in where you're like, hey, can you add a feature so that I can turn this off and blow it up? It probably doesn't get too high on their priority list. So Chaos Studio, it doesn't have a lot of integrations, and it's kind of simple. You can really break it up into two components. You have experiments, what I want to do, and then you have the targets. Who am I doing it to? For an experiment, you break the experiment up into, its hierarchy is broken up like this. So there are steps. Within steps are what things that run concurrently. So steps have branches. So if in step one, I have failover Cosmos DB, and then for my VMs, shoot the memory up to 99% usage of memory. Right? So let's say I hit both of those. If I do those in the same step, they happen concurrently at the same time. And that's each action in a branch. So you have steps. In a step, you can do multiple things to different, like multiple targets. And then you can have actions within those branches. And you can have multiple steps in your experiment. Does that make sense so far? Okay. And this is the actual diagram Microsoft used, so we'll use that to further emphasize the point. I have an experiment, step one, branch one, action one. And my first action would be, let's take the CPU pressure to 99% on all processes. Branch two is some different kind of fault that I want to run, like turning off Cosmos DB or shooting the memory up too much. And then after that, so branches run at the same time, but then steps are sequential. They run one after another. Okay, then we have targets. You're going to list them by resources, or you're selecting resources with selectors. So the same picture, except this time we're doing it by selectors. You create a named selector, and then you put in the resource IDs of what you're trying to do. And I'm not sure exactly how fancy selectors could get, but I'm assuming you're eventually getting to where you can have tags and whatnot. But right now, I think the resource IDs is what you primarily focus on, because if your selector query is wrong, I don't think you want to know what all you pulled into your experiment. You can break down faults into about as many categories as you want, but there's 6 that they really talk about. Destructive, whatever the instance is, it's gone. Like whatever it was, it's gone, it doesn't exist anymore. We want to see how the system reacts. We can apply pressure to the system. So for those containers, I want the CPU to hit 99% and hold. We can add latency. We can change configurations of different services. And then we can apply that for a duration, and we can actually parameterize those. So there are 2 major types of faults. And they make a lot of sense if you're deep in the Azure world why they did it this way. But there's 2 types. There's service direct, and then there's agent-based. And you can run these cross-subscription and cross-tenant if you need to set up an experiment that actually if you're doing a cross-tenant experiment, I don't know what you're, like, that's expansive, but cross-subscription would make sense a lot of the times if you have your subscription set up with different components in your tenant. Cross-tenant, it's available, but has anyone ever had to do anything cross-tenant when you're doing things in Azure?
Does Azure AD count?
Yeah, I mean, it can, yeah. I mean, if you got to do anything cross-tenant, the CLI and the portal and all that, they don't like it. You have to give everything its proper service ID and then map it to the tenant ID, and it's no fun. For security purposes, and I think I said this earlier, before you can inject a fault, you have to tell the service that it is allowed to do that. right? Before, like if I create Cosmos DB and I want to do the thing to it, it's not just auto-enlisted able to do that. You have to tell it that it has the capability enabled within Azure to do that. So to restrict this, you're either going to use the Azure Resource Manager. So the Azure Resource Manager is the component that allows that capability to be turned on. I don't know if you've ever had to deal with the capabilities where it's that really nice long string of like read-write access. It's like, yeah, it's that. But you have to turn on the capability specifically for whatever you're asking that component to be able to do. It has to run on a managed identity, right? No users can do this. It has to be a managed identity that turns these things off. And you have to explicitly onboard each instance. So it has to have the capability and you have to onboard it. So that way, anyone here who's worried about turning on Chaos Studio in your own environments, this is all that's required for it to actually be enlisted as something that can be affected by a fault.
System identity or user identity? User managed as well?
For Chaos Studio uses the managed identity to communicate with.
The system automatically generated one, or can it be one because you can create the user managed identities that you assign to the same identity to a dozen resources, or just the automatically generated one that you have no control?
I don't know exactly because I've mainly done it through the portal.
Which means unless you've been creating the identities yourself and then assigning them to the resources, you're using the system one.
Right. And so I am using the system one. That's why I said it that way. I don't know if you can because I never tried it, but you might be able to when you onboard it using the CLI. But when you do it through the portal, if memory serves, it does not ask for that identity. It does it itself, I think. Okay, for agent-based, let me just go through this. Managed identity, agent-based. Agent-based, forget those slides. VMs, right? If I'm gonna run it in a virtual machine, the operating system on that virtual machine has to have a service running within it. So that's the agent that is going to be doing all of this stuff against the virtual machine. And really that's the only reason agent-based exists is because virtual machines are so far removed from the capabilities of the Azure ecosystem. I shouldn't say it like that because you can really integrate that. They are separated because your virtual machine might just be that thing that was built 20 years ago and has no idea of anything that exists outside of its world. So you have to install a service on it that it can interact with. Does that make sense? So that's agent-based. So that's one of the two types. The other one is service-based. I missed the title on this one. Service-based are things that Azure actually can control and manipulate. So it can be a service-based, service-direct. So that is something that interacts with an Azure resource directly, meaning like Cosmos DB, it can say fail over, crash, something like that. That's service direct. For service direct for AKS, you're still interacting with it directly, but you have to install the Chaos Mesh agent container. You have to install it into your Kubernetes cluster to interact with Kubernetes. And then finally, the agent-based faults. And then Chaos Studio encrypts all data by default. Let's do a demo, because I just want to see it, right? That's all you really care about. Any questions before we get to the demo? Okay. Don't get rid of me if I mess up the demo, because again, I'm not an expert with Chaos Studio, so I've done this before. If you look at their documentation, there are 3 examples. There's your Kubernetes, your VM, and your Cosmos DB. Let's do Cosmos DB because it was the easiest one. It was hardest to screw up. So we can take a look at that. It kind of shows up live because I'm not installing an operating system and creating VMs and all that. So
The fastest one to get to.
yeah. Let's see. So let's create our Cosmos DB from scratch. There we go. Code on the beach. And we will use the East region because it's in Virginia and I think the closest.
East 2 is a bit closer, but
To here?
East 2 I think is North Carolina.
Oh, okay. I'm from Atlanta and East 3 is going to be in Atlanta.
Where's their failover going to be?
Oh, for me?
For East 3, I mean, or have they said yet?
I'm not sure. I know that they have 3 availability zones going up for it. I'm not sure where the failover is. Sorry, I'm reading to make sure I'm doing things right. Yes, apply the free tier discount. Wait. I think we need geo-redundancy. Yes, so we need geo-redundancy, blah, blah, blah. I don't think we need anything else.
I don't know. I was not even touching the ball. He said something with some word.
Thanks. So we'll wait for that to deploy, and then what we're going to do is we're going to go back to Chaos Studio. Chaos Studio is not an instance. So when you go, you're not putting it in a resource group, you're not putting it anywhere. It is a global, just like if you're going to Azure Active Directory, it's global. So you don't go to a specific instance, you just go to Chaos Studio in Azure.
So you could be thinking you're testing QA and could actually be knocking down your production?
If you onboard it.
I mean-
If you onboard your production.
I mean, you can do a lot of things. I don't know if you get to the situation where you accidentally took down production, your policies are not set up correctly, because your policy should in Azure say in your production that that capability can't be enlisted in that environment. Yeah, unless you're Netflix. And Netflix, I've got time. I'll go to my soapbox. Netflix was somehow like a third of AWS's total billing at one point, or something ridiculous. And like most of the movies went through Akamai's network. And I still don't know how they use so much compute resources to put all the movies in the same, like every category was the same set of movies anyways for me. So like, I don't know what exactly was going on behind the scenes to cause that. And then they said, just take down your production environment. I'm like, this is a little bit different. It's a little bit different, Netflix. If you take down your production environment, the movie doesn't go down, it still goes through Akamai. You're just taking down the AWS part of it that, again, does login or whatever else.
Even if you took down Akamai, they've got it, quadruple redundancy for every
Yeah. If
resource?
you took down Akamai, you were like a government-sponsored thing. I don't know how to keep you guys entertained while I'm deploying Cosmos. I didn't expect it to take this long. Any more questions? Anybody want to know something about Azure? Cosmos? In the back.
So, the blast radius was brought up earlier. And let's assume for a second that some people raised Netflix challenge. How does Azure, how are the controls to stop your chaos event once you've started it, if you see that you've exceeded your
Let me show you in the portal if I can show it. It's got a button that says stop.
How quickly does it stop?
How quickly it stops going to be. So it depends on the resource and what you're doing with it and how it fell over. I mean, if we're talking about VMs, how they react and how your system reacts is going to be dependent on. So it created the resource. It just doesn't know it created the resource. Like VMs is going to be dependent on how your VMs handle it, right? And then for Kubernetes, same thing. For Chaos, for Cosmos, we'll just test it right now because it'll fail over and it'll do the swap to the appropriate region. What I'm thinking is if you stop it, because of how Cosmos works, I don't think Cosmos automatically turns you back to the original region. You have to tell it that because after it's failed over, it doesn't want an interruption to service unless you tell it to have that interruption to service. So I don't know, is my full answer.
It's one of those things that I would want to theory of practice in pre-prod with replay before I
Right.
bring something in prod.
I don't have a client that I could suggest this to do in production without being walked out. I really don't.
Especially on something like Cosmos or, well, I'm guessing for the VM it just makes it believe that the CPU and the RAM is dead.
I think it just uses cycles for CPU, for memory, it just floods memory.
Turning it off could be really painful.
Right,
Instead of
yeah.
having it be frozen.
Right. So I don't know how you would do this with that. Okay, so I've got Cosmos DB. I need to set it up so that I have. All right, so we're going to enable multi-region rights. It's going to bill me for that. I'm going to save that. So just to note, because I didn't really walk through, and for anyone on video, all we're doing here is we're enabling the multi-region writes. So previously we had that disabled. That means if you were in the East region, you're not getting any data replication. We turned it on so that now it's in the East US and West US. So when you do a write, it replicates so that when we have a failover, we can properly failover. Okay. Now let me see on overview. Oh, it's still saving. Okay, well, we're still doing that then, I guess. That is created, so let's go home. Let's go back to Chaos Studio. Let's go to our resources. We'll go here. You are already enabled. Okay, so you see here on the left, we've got targets and experiments. If I want to create an experiment, we just click on create. We have to give it a name. Code on the beach. We have to put it into a resource group. Okay, and now you see we have steps and branches so that we can start writing these out. So step 1, fail. And then the branch, Cosmos. And then we want to add an action. We're going to add a fault. Cosmos BDB failover. We're going to do it for 10 minutes. We're going to do it in East US. We're going to do it to our code on the beach instance. We're going to click add. So now in our first step, we're just going to fail that Cosmos DB instance over.
I'm guessing it only shows you the resources that match the type of failure. So if it's at an AKS failure, it won't let you.
Correct. We'll only allow what should be related, I think. Okay, and so we can see here reads and writes are enabled in both East US and West US. We have created our experiment. And let's run it. Okay, so now with everything else you've seen in pipelines, we've submitted the request. It'll take a second, it'll pick it up and it'll do it. And I will try to keep watching on this page to show that it did it. And then, before it's done, we're going to stop it and see what it does to roll back. And now I don't know what to tell you to entertain you during this. Look, whoop. It failed. We'll see what I did wrong on this demo. So as I said, you have to give it the capabilities to do that.
It let you enable it, it just didn't let you.
Right. And I am not going to lie. For those on YouTube and those in the audience, I don't remember how to do that. So I am going to go to the sample, and we will do that as a team.
Tutorials.
Yep. Let's see. Service-directed faults in the portal. Create the Cosmos DB account. Enable. See what I'm doing wrong here. Capabilities, subscriptions. Do I need to do this from the command line? I need to do what?
Subscription.
Help me out. I just heard the word subscription. I don't know what that means.
There is a subscriptions in the account, home account. I don't know whether.
Yeah, I think if you click on your person up in the right-hand corner.
Mm-hmm. I mean, I think I'm on the right subscription.
Fine, because you're on your MVP subscription.
Mm-hmm.
What are my Microsoft accounts and their settings there?
Actually, on here in identity.
Mm-hmm.
But again, I don't know which subscription you have to subscribe.
I've only got the one, so this will be in my my Microsoft subscription.
That part's fine.
Yeah, I'm in my MVP subscription from Microsoft. So I think that's fine. What I think I haven't done, I'm going to go back to my resources. I'm going to go to that Cosmos DB instance, and then I want you to talk amongst yourselves while I stare at it for a minute and try to remember what I'm not doing properly.
Features or identity, maybe. Identity.
Mm,
There is no identity, so there's nothing to run it as.
system assigned.
You have to turn on the identity.
I believe you, and I trust you.
Well, that's.
And we're going to.
The identity on.
We did. We did. I mean, everything you're saying sounds so right, and we're going to try it. Because my apologies, I don't remember what I'm missing.
Yeah, we'll let you turn it on.
I just need to refresh. All right. Thank you, Cosmos. Do you want to enable? I do want to enable. Error.
Oh, and the best type of error.
If I had to guess, I'll use my great fallback. So this is a preview service.
And they won't let you do it on MVP. They won't let you do it on MVP.
And you know, sometimes reference by the experiment could not be found due to information insufficient. It's one of two things I'm missing. I either didn't turn on the capability, which I'm pretty sure the capability is on the account, on the subscription for Cosmos DBs that I can do that. I think. I mean, I've run this experiment before, but more likely I have something somewhere where it created a managed identity, and then it's not assigned properly because it won't let me create a new managed identity. It says there's an error, and then it's saying over here that it doesn't have access to it. So let me disable. Let me try one more thing, and then if that doesn't work, you can all just leave terrible reviews and say that guy doesn't know what he's doing. But don't do that.
Now, before you enable, after you refresh, before you finishes, still disabled.
Yeah, it's going over here.
Try creating the managed identity before you re-enable it.
Okay.
What's that link at the top that says subscriptions?
That is your list of which ones you have available.
What are we looking for? Everyone keeps saying there's a list. Are we talking about the list here? List here?
That list.
Directories and subscriptions? I should have just the one right here where I've got my subscription and the default directory. So I don't think that, I don't know if that's it. So now it says that there's a system assigned identity.
What about that bottom button? It says Azure.
That's to give it permissions that's to give the identity permissions to do some of the other APIs.
Well, let's see if that has the capability.
Do it with the subscription button here, because
And then we will go with chaos. Cosmos. We'll give it the Cosmo DB operator. We'll see how badly I can break my subscription. Yeah, man.
No worry, we'll help you.
Thanks, guys.
2019
So I've been doing Azure stuff for so long that if I actually do break anything in my subscription, it's not going to change how badly my subscription runs right now. Because, I mean, I was there before the Office 365 split, so all of my identities are still live accounts, but they're not because it used two email addresses for the same one, and they had to merge, and blah, blah, blah. So it's not really going to like break stuff too much more than it already is. All right, so thank you all for bearing with me. We'll try Chaos Studio one more time. We will create this.
you should be able to reuse the same.
Well, let's see. Let's just do it. I mean, why not? Go down the beach. 2. Let's use the experiment designer. We're not even going to add names. We'll add a fault. Fault. And then the read region will be East US. And then it'll take another 10 minutes to create this. And so talk amongst yourselves. And oh, nope, done. All right, shush. I will try to start it, and if it doesn't work, we'll go to questions.
If it doesn't work, it's okay.
Touche.
It's too chaotic for itself.
Yeah.
We have the
It failed again. So my apologies. I am missing something in some step somewhere, most likely having to do with capabilities of the managed identity, or the preview's broken, which hopefully, I don't know. All that really happens, because now that it's taken so long, if I actually did get it to work, all that happens is when we run this, if we go back to the Cosmos DB instance. It just shows you that it failed over. So that is not the most entertaining of outputs at this point that it's taken so long to get it set up. All it does is it show you that it did fail that region. You can all use your imaginations. Where it has right there in the east region, just imagine those check marks aren't there.
So how does it actually simulate that failure? What does it do?
How does it simulate that failure? With the capabilities enabled for Cosmos DB, I believe all it does there is just change your configuration in Cosmos DB that it no longer has East US as a replication region. So for Cosmos DB, I think it's just that. For the others, it has to do with how it's interacting with Kubernetes and how it's interacting with the VM.
When
Oh, there you are.
there's an option to add latency, when it says, okay, add latency, what is it actually doing to add latency?
I'd have to check for what it's doing to the VM. I believe it's a Linux-only agent, so I'm assuming that it's running as some permission that can actually interact with the virtual network. Yes?
Is there any type of precondition checking or precondition checking that you can automate into an experiment? To use the example of the Active Directory failure that you discussed, making sure that if one system's at 50% load or one's at 60% and the other one's at something higher than 40%, their load balance, that we don't turn one off.
All right, there is not currently available anything like that, but that has been feedback that myself and others have given, that to do that right now, their suggestion is multiple experiments, right? Run an experiment, check, and then either stop that experiment or move on to your next experiment. So yeah, they need a lot more so that it's a seamless experience as opposed to what it currently is, in my opinion.
Yeah.
All right, that's me. Don't tweet at that telling me how bad that demo went, and we're all good. So thanks, everybody.